Welcome students for the class of science for the class 10 students, and the topic we are discussing here is acceleration due to gravity on the topic force. On my last class there was a necessary discussion, so today I will just give you a note of important part of this acceleration due to gravity. So first of all, please focus in my writing. The first important thing that you should know is what is acceleration due to gravity. Now, the acceleration produced on a freely falling object towards the center of planet or satellite is called acceleration due to gravity. So my dear students, so this is how we have to write in our examination. The acceleration produced on a freely falling object. Freely falling means without any resistance. There is no resistance on the fall. For example, when the coin falls, that is freely fall. But when the paper falls, look the falling of paper. That is not freely fall. Remember, towards the center of planet or satellite is called acceleration due to gravity. It is symbolically written small g. Small g. And there was another g. Remember? In my before class, in probably my second class I think, there was another g, capital G. That was gravitational constant. This is acceleration due to gravity. Remember. And its value. The second thing you should remember is its value, its average value. Its average value in Earth's surface is 9.8 meter per second square. Remember, its average value on our Earth is 9.8. It is different in different planets. We know that there are some planets smaller than Earth. There will be the less value of G. There are planets bigger than Earth. There will be more than the value of G on the Earth. For example, in Jupiter it is around 25 meter per second square. But in the moon it is just around 1.67. So there are huge gap. Remember, they all are because of the difference in the mass. Okay? So it's average value. And the next thing that you should remember is the effect of acceleration due to gravity on the object. That was what I was explaining on my last class. Look here. What I explained, this is what we should write. We explained a small activity to prove that the acceleration due to gravity is equally falls upon all objects. Now I will write you an activity which is a very important one. Activity. Draw a coin and a paper. A same moment. Notice their fall. Notice. The first question is, did they together reach ground? के तिनीहरु सँगसँगै ग्राउन्डमा पुगे? त्यो चाहिँ एकदम हामीले नोटिस गर्नु पर्यो। त्यसै गरी second thing that I will write you here is about the two stones. Second activity Second activity. Draw 2 stones of different size together. Sorry, together. T-O-G-E-T-H-E-R. Together, please. Different sides together and notice their fall. Notice their fall. Student, you also have to copy it. Don't forget. Number 1. Did they together reach ground? Okay. So यहाँ मैले दुईटा एक्टिभिटी बारे कुरा गरेको छु। यसैको बारेमा हामीले डिस्कस गरेको हो हिजो क्लासमा, लास्ट क्लास भनौँ, यसै बारेमा कुरा गरेका थियौँ। सबैभन्दा पहिला के गर्नु पर्यो भने हामीले चाहिँ लैजाएको छ है। ड्रप 2 stones of different size. एउटा ठुलो एउटा सानो खसाउनुस्, त्यसलाई नोटिस गर्नुस्। सँगसँगै ठोक्कियो कि ठोक्किएनन् पक्कै पनि। यसको एन्सर चाहिँ they reach ground together. यिनीहरू ग्राउन्डमा सँगै पुग्छन् किनभने एक्सिलरेसन ड्यू टु ग्राभिटी यो चीज यो सेन्टेन्स चाहिँ तपाईहरुले अब धेरै एन्सरमा जोड्नु पर्ने हुन्छ। यो मात्रै हैन, ड्यू टु ग्राभिटी is independent to mass. किनभने एक्सन टु ग्राभिटी मासमा भर पर्दैन, चाहे ठुलो होस् चाहे सानो होस् बराबर हुन्छ, त्यो सँगसँगै खस्छन्। अब यता अब यही चीज यहाँ चाहिँ लाग्दैन। ड्रप अ कोइन एन्ड अ पेपर एट द सेम मोमेन्ट। सँगसँगै खसाउनु। नोटिस द फल। खसाइले हेरौँ है। सिक्का र पेपर सँगसँगै खसाउँ हेरौँ भनेको छ। अब यसो हेरौँ। अब भर्खरको एन्सरमा चाहिँ सबै अब्जेक्टमा एक्सन टु ग्राभिटी बराबर पर्छ भनेको छ। अब यता हेरौँ है। खसाइयो। कुन चाहिँ पहिला पुग्छ? अब सबै भनिन्छ। अब सिक्का पहिला पुग्छ। देखेको पनि हो। कागज र सिक्कामा त सिक्का पहिला पुग्छ। अब यहाँ फेरि के समस्या आयो त? हो, here is one problem, that is although the accelerated gravity is equally applied, the fall is not free fall in the paper. सबै अब्जेक्टमा स्मल g को भ्यालु चाहिँ बराबर भए पनि पेपरले बढी एरिया कभर गरेको हुनाले यसको फलमा चाहिँ एयरको रेसिस्टेन्सले बाधा पुर्याउँछ। यसको फल चाहिँ फ्री फल भएन। कोइन चाहिँ फ्री फल भयो, पेपर फ्री फल भएन। There is equal g, but the fall of paper is free fall. That is why we should understand. मैले फेरि पनि एउटा कुरा बुझ्नको लागि यहाँ के काम लाग्यो भने एक्सन टु ग्राभिटी सबैमा बराबर पर्छ, तर बाहिरी कुराले पनि यसमा इफेक्ट गर्छ। यदि चन्द्रमामा लगेर गरियो भने कोइन पेपर सँगसँगै खस्छन्, तर यहाँ मिलेन, यहाँ हावा छ। त्यसले गर्दाखेरि यो पेपरको खसाइ फ्री फल नभएको हुनाले यहाँ चाहिँ जी को प्रभाव भन्दा पनि यहाँ रेजिस्टेन्सको प्रभाव बढी भयो, त्यही भएर चाहिँ यो खसेन। त्यसैले एक्सन टु ग्राभिटीले प्रभाव पार्ने चीजमा के पनि पर्न सक्छन् भने अब एक्सटर्नल एयर रेजिस्टेन्स, एरिया कभर्ड, it may decrease the value of g on the object. This is the main thing. So this is what we are writing here, and the main thing that you will achieve today is what are the things that may affect the accelerated gravity. Remember. Okay. So coin reaches the ground first. It is because your important answer. It is because fall of paper is affected by external air resistance. External air resistance. So value of small g is decreases on paper. So my dear students, so you should understand this is accidental gravity. We are talking about a big thing. This is going to be a very important part in this chapter for you to write in examinations. So you should understand two things now. Acceleration due to gravity is equal for all object irrespective of masses. Number two is it can be affected by external air resistance, the area covered by the object. So you please try to understand me that हामी प्यारासुट लिएर चाहिँ खस्दाखेरि हामी सजिलै यहाँ फल गर्छौं, तर प्यारासुटको काम किन गरेन भने चन्द्रमामा त्यहाँ चाहिँ हावा छ, फ्री फल हुन्छ, चाहे जति नै होस्। यो यसको बारेमा म फेरि पछि जोड्नेछु। So in the next class. So thank you for this. Wait for my next class and stay tuned. Thank you.